Hello students, in this video lecture we'll discuss chemistry chapter 2. The name of the lesson is acid, base and salts. Students, what do we know about the acid and bases from the previous classes? Acids are those substances which taste sour and turns blue litmus red, and bases are those substances which tastes bitter and turns red litmus blue. But students, in this class we'll discuss something new, the new definitions of acid and bases. So what is acid and base? Those substances which on dissolving in water furnish H plus ions, hydrogen ions, are called acids. And those substances which on dissolving in water furnish OH minus ions, hydroxide ions, OH minus ions, hydroxide ions are called bases. So student, any substances which on dissolving in water if generates H plus ions, if the substance generates H plus ions on dissolving water, such substances are called acids. And if the substances on dissolving water generates OH minus ions, hydroxide ions, such substances are called bases. Here are some of the important examples of acid and bases: HCl, hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, acetic acid. And these are the examples, important examples of a basis: sodium hydroxide, potassium hydroxide, ammonium hydroxide, and many more. Students, let's move on to another topic, the pH value of a solutions. Every solutions, whether it's acidic or basic, to every solutions we assign a numerical value to indicate the strength of the solutions. Strength of the solutions, whether the solution is more acidic or less acidic, or whether the given solution is more basic or less basic, to indicate its strength, whether it's more acidic or less acidic, or more basic or less basic, a numerical value is given to a solutions. So the numerical value which is given to a solutions, that numerical value is called a pH value. So that is what? Power of hydrogen, pH value. Students, pH value of a solution ranges from 0 to 14. That means every solutions can be given pH value from 0 to 14. Here we have scale to understand the pH value. So this end of the scale we have a 0 here. This is pH value 0, and the another end of the scale we have a pH value 14, and the middle of the pH value 7. So any solutions whose pH value is less than 7 is said to be acidic. So solutions having pH value less than 7, they are acidic, and the solution having pH value more than 7, it's a basic solutions. Now student, what is the meaning of high H plus and low OH minus? High OH minus and low H plus, and H plus equals OH minus. Student, suppose I have a acidic solution here. Let's say suppose this solution is acidic. As I mentioned, acidic substances are those substances which on dissolving in water generates H plus ions. Now if this is acidic solution, now acidic solutions definitely will have a amount of H plus in it, but student, acidic solution also contains OH minus ions. That means acidic solutions contains both H plus and OH minus ions. So the acidic nature of this solution is because the quantity of H plus is more than that of OH minus. Similarly, suppose I have another solution, basic solution. So in this basic solution, the basic character is determined by OH minus ions. So this solution definitely contains OH minus ions. But that doesn't mean these solutions will not have H plus. This solution also contains H plus. Means basic solutions and acidic solutions both contains H plus and OH minus ions. If solution is acidic, the quantity of H plus is more than that of OH minus. If the solution is basic, quantity of H plus is smaller than OH minus. If any solution contains H plus and OH minus equals, we say such solution as a neutral solution. So neutral solution have a pH value of a 7. pH value of 7. So that's what we mean by this high H plus and low OH minus. That means any solution where H plus is high and OH minus is less, such solutions are acidic solutions. And any solutions where OH minus is higher, H plus is less, such solutions are basic solutions. And the solutions where H plus and OH minus quantity are equal, such solutions are said to be neutral solutions. Now student, pH value and hydrogen ion have a relation. They have an inverse relations. Higher is the pH value, smaller is the H plus ions. Means the quantity of H plus will be less in the solution. And pH value and acidity also have an inverse relation. Higher is the pH value, smaller is the acidity. Lower is the pH value, higher is the acidity. So if you have a more H plus in a solution, the pH value will be less. pH value is less means the solutions will be acidic or highly acidic. Now this scale explains the variation of H plus and OH minus with the change in a pH value. Student, you start from the 0. Observe carefully this end of the scales. This entire scale have a two regions, shaded region and unshaded region. Shaded region indicates H plus and unshaded region indicates OH minus. Now this end of the scale where the pH value is 0, you can see the shaded region is more. It means H plus quantity is high. And at this end of the scale, we have a very less unshaded region. It means the quantity of OH minus is very, very less. Now when you move towards the right side of the scale, you will see the shaded region goes on decreasing, and at the same time the unshaded region goes on increasing. And the moment you reach the middle of the scale, that's the pH value 7, you can see the shaded region and unshaded regions are almost equal. Or we can say the area covered by the shaded region and unshaded region are almost equal. It means the quantity of H plus and OH minus are equal. The solution is neutral. If you keep on moving towards the right side of the scale, you will see the shaded region goes on decreasing and the unshaded region goes on increasing. It means H plus concentration is decreasing and OH minus quantity is increasing. So at the extreme right end of the scale, we have a pH value of 14, where you can see the unshaded region is the highest and shaded region is almost negligible. That means H plus quantity is negligible and OH minus quantity is present in excess. So the solution is basic. So this is the basic definitions and a meaning of a pH value. I hope student you understood what is acid, what is base, and what's the importance of a pH value. We'll discuss now. Let's move on, student. Let's try and understand what is the importance of a pH in our everyday life. Here I have mentioned some of the important points that shows the importance of a pH value in our daily life. So first of all, plants and animals are pH sensitive. That means a narrow change in a pH can affect a living body, living being drastically. Student, our body works within a narrow pH range of a 7 to 7.8. That means our body works in a very small or narrow range of a pH 7 to 7.8. That means our body can tolerate a pH change of a 0.8. If pH change increases or exceeds 0.8, that can be dangerous. One simple example we can understand, our body releases H plus. Our digestive system releases H plus. Now suppose student, when you're suffering from acidity, what happens? You feel uncomfortable, irritations. From those experience only you can understand what is the importance of a pH change. So this value is very important. Our body works in the pH range of a 7 to 7.8. Now student, one more important point that we must remember, acid rain have a pH value less than 5.6. That means if the rainwater, the pH value of the rainwater drops below 5.6, we say the rain is acidic. An acidic rain can cause damages to the soil. If the acid rain falls on the soil, that can destroy the fertility of the soil. If it falls on historical monuments, buildings, that can damages the shine of that buildings. So that's about the acid rain. Now next point, student, pH in our digestive system. As I mentioned just a while ago, that our digestive system releases acid. So H plus, when HCl, hydrochloric acid, released in the digestive system have a pH value of 1.2. Now student, you can understand the value of the pH value is so low. The pH value of HCl is so low, and pH value less means highly acidic. So this acid is very strong acid. Excess of acid form in our stomach causes irritation. To neutralize the excess acid, milk of magnesia, magnesium hydroxide of a pH value 10 is given. Now student, milk of magnesia, it's a mild base, the pH value of a 10. So if you suffer from excess of acids in your stomach, to neutralize the excessive acid, milk of magnesia mild base is given. So if you consume this milk of magnesia mild base, that neutralizes the excess acid formed in our stomach, and we get rid of all the irritations and uncomfort. So that's the importance of a pH in our digestive system. Next student, pH change is also the cause of a tooth decay. If pH in our mouth falls below 5.5, tooth decay begins. Tooth decay starts. Now students, sometimes or many a times when we consume food containing sugar, so after the consumption, the bacteria present in our mouth decomposes the sugar into acids. If the pH value of the acid drops below 5.5, that dissolves the polish, the enamel of our teeth, and that's the beginning of tooth decay. So student, if the pH value falls below 5.5, the acid's pH value falls in our mouth below 5.5, the tooth decay begins. So after the consumption of the food containing sugar, we must brush our teeth with a basic toothpaste. So base containing toothpaste neutralizes the acids formed in our mouth and prevents tooth decay. So that's about the pH as a cause of a tooth decay. Next comes the student, self-defense by animals and plants. Sting of honeybee. Ant injects methanoic acid. Now student, remember the name of the acid which is present in the sting of honeybee and ant. They have this methanoic acid. So whenever this honeybee and ant bites us, they inject this methanoic acid that causes that burning sensation on our body. So if we apply a base around that stung area, that neutralizes the acids and gives us relief. I hope student you understood the importance of pH in our everyday life. So with that, we conclude today's discussion. So we'll discuss more about the acids and its properties and some of the important compounds in our next lecture. Thank you.